Okay, so at this point I'm assuming that you have your Vortex already installed in your helicopter. Everything is plugged in and ready to go. The one thing that I recommend people to do at this point is not to connect the rotor servo yet. Leave your tail servo unplugged simply because depending on the setting for your tail servo, the rate that it operates at, it might not, the Vortex might not be compatible with that immediately. So you want to make sure that you set that first, then you plug in your tail servo. So anyway, Spartan Vortex is already on the helicopter. If you have an S-bus system, your receiver is already installed on the helicopter, you have it plugged into your RX port, and you have already a connection between your transmitter and your receiver. If you have Spectrum, like in the case here, and then you have your satellites already plugged into the Vortex, you have your radio already selected to a certain channel that's ready to go, a blank channel, a blank template. There's some templates that are kind of ready to go. They're available at the Spartan-RC.com website. You can download those. They're available for a few radios, but normally this is not very complicated. This is actually quite easy to do. Next thing is, if you have a nitro helicopter, you obviously have already power somewhere in the helicopter in the form of, say, a 2-cell LiPo or so. If you have an electric and you're relying on a BEC that's built into your ESC, I encourage you not to use that for the setup. There's just no need to be messing around with that. I'd rather you use a separate receiver pack to power your Vortex while you go through the setup motions. Either that or, again, the Scorpion backup card. Either one will work really well. If you don't have an available port on your Vortex, don't worry about it. You do not need one. You can power the Vortex via your data pod. Yes, you can, believe it or not. It's really cool, actually. So go ahead and plug in the data pod to your Vortex. As you can see here, I have a little extension installed on my helicopter, and it stays there all the time, and it just makes it easier for me when I'm at the field. If I want to make a quick change to the parameters or something, I can just plug in my data pot with ease without having to kind of go right into the port, especially in this particular setup right here. So right now I have a long extension here to facilitate the shooting of the video, and I have my data pod already plugged into my Vortex, and I'm going to go ahead and power on my Vortex right now. And again, I don't have an available port, but I'm going to power on my Vortex through my data pod. So I'm just going to feed power. I'm going to plug in this 2-cell LiPo to this other port on the data pod. And that is going to power on the data pod, and it's going to power on the Vortex at the same time. So as soon as you power on the data pod, the first thing you look at here is the main screen of the data pod. And this screen is basically some sort of display screen. It just shows you some basic stuff. It shows you how many volts you're feeding into your Vortex, shows you whether the governor is active or inhibited, your throttle setting right here, your flight modes, which we will talk about later, and so forth. And there's different screens on the data pod. There's basically 5 screens. There's a rotor, a tail, a governor, a system, and a setup screen. And the most important screens you need to worry about are the rotor and the tail screens. Those are the screens where you're going to go to the most often to make changes to the way your helicopter flies. The setup screen is the screen you need to go to first to obviously do your setup. And then your system screen just has miscellaneous stuff. You can look to see how many fail safes you had if you were flying Spectrum, or how many satellite changes you've had. You can go there to, for example, set up a trim flight. But you know, system screen's not as important. And of course, the governor screen, you only need to access it if you're going to be using the built-in governor that the Vortex has. So anyway, you have 3 buttons here on your data pod. You have an S button right here, which stands for select, and then you have a negative and a positive button. So if I push on the S button, it moves me around the different screens. So the name of the screen appears right here on the left hand side. And as you can see, this is again the main screen. If I push S, it takes me to the rotor. Push S again takes me to the tail screen. S again takes me to the governor screen. S again takes me to the system screen, and then to the setup screen, and back to the main screen. So if I push S and then I move the plus or minus signs, this moves me up and down. And if I were to push S again, I would be selecting that option. If I move it all the way up, it shows next, meaning it'll move to the next screen. So I'll push S, and I'll keep scrolling through the screens until I come to the setup screen. And there we are. Setup screen is the first place, again, you want to go to. And you want to work your way down from the top. So the first option here below next is receiver. That's where we want to go first. So you select receiver and you push S. And then it gives you the types of receivers. It wants to know what kind of receiver you're running. So we have all these options here. Obviously, if you had Futaba, again, your receiver will be already plugged in and bound to your radio, and it would be up and running, and you would select S bus, and that would pretty much initialize the data, the vortex. But because I have a Spectrum, I'm going to select the type of antennas. I have the receiver antennas. I have DSMX, so I'm going to select that, push S, and then I'm going to tell it how many antennas I have. I have 2 antennas, 2 satellites, so I'm going to push S again, and that takes the system immediately to bind mode. So my antennas are blinking right away. So I go back here to my radio, I hold the bind button, I power it on, and that should bind my receiver.
DSMX 11 milliseconds. Bind complete.
And that's it. Now I'm bound. Once you bind with Spectrum, make sure that your data pot reads bind complete, press S. It is very important that that shows that. If it doesn't, then please don't fly. Just do the bind process again. Push S, and then the next screen here shows me basically what channel corresponds to what function on my radio. And normally this is perfect right off the bat, but I want to double check to make sure everything's good. So I'm going to go to my monitor screen on the radio, and monitor simply because it's the easiest screen to look at. And as you can see here, I have all my channels, throttle, aileron. So I go back to my data pot and I look, and it's showing me aileron channel should be channel 2. S2 is highlighted. Look at my radio, 1, 2, channel 2 is aileron. Then this is correct. So I push S, and it shows me elevator is number 3. I go back to my radio, 1, 2, 3, elevator is channel 3. So that's good. So I keep going through these options by pushing the S button and double checking that everything is correct. Rudder is 4, pitch is 6, throttle is 1. And if something was incorrect, you can just move that channel around by pushing the plus or minus buttons here. Channels, throttle is 1, gyro is 5, and that's it. Now that completes the receiver portion of the setup. And I push the plus sign here, and I go down to transmitter. So the transmitter is where we calibrate the transmitter to the vortex. So I push the S button, and then it's asking me if I want to use flight modes. I'm going to go ahead and tell it no for now, but we will go ahead and revise the flight modes here after we're done with the setup. I'll explain what they do. If you have a governor, you have to activate these, but for now, we're going to go ahead and say no. And then, as you can see here, we got a live graphical sort of rendering of what the radio is doing. As I move the radio sticks, all these things start to move. And this is basically simulating the right stick on a Mode 2 radio. So the stick simulating up, down, right, and left. And then we have rudder. So when you move rudder, this moves. And when you move pitch, this moves, and throttle, and so forth. So the first thing we got to do is make sure that our main functions are not reversed. So let's go ahead and start with the right stick. So if I move the stick up, this little ball should move up, and that is correct. If I move it right, this ball should move right, but it's not. It's moving in the other direction. So how do we fix that? First screen we want to go to on our radio is the servo reverse screen. And so far we can tell that aileron needs to be reversed. So go ahead and reverse that. Now if I move the stick to the right, this moves to the right, left it moves to the left, back it moves back, forward it moves forward, so that is correct. Then I'm going to check my rudder. If I move rudder left, this should move left, but it moves opposite. So we're going to go ahead and reverse the rudder on the radio. Now if I move rudder left, that moves left, so that is correct. Next, we'll check the pitch. That's negative pitch, minus 95. Positive pitch is moving up, that is correct. Throttle is also correct, although throttle is not as important. I'll explain that here in a minute. And then gear, we'll talk about gear later when we talk about flight modes, as that pertains to flight modes. For the moment, you really don't need to worry about that. So next step is we're going to go to our sub-trim menu on the radio. And we're going to sub-trim everything on the radio until we see zeros here. As you can see, this is +3, this is -1, rudder's -1. We want to see 0 everywhere in there. I'm going to go to aileron, until I see 0 here. That's 0. And I'm going to go to elevator until I see 0 here. Let's see here. And that's 0. Then I'm going to go to rudder. I'm going to move this until I see 0 here. And that is 0. Then I'm going to pitch. So to get center stick on the pitch, I go back to the monitor screen on my radio. I move my pitch up until I see 0 on my pitch. 0 should be right there. Then I go back to my sub trim screen here. I check my data pot. Oh, and pitch is already at 0, so I don't have to change the sub trim for pitch. Throttle is, as I said before, it's not that it's not important, but if you're going to use a nitro helicopter to where you're going to use the built-in governor function of the Vortex, then you do have to calibrate your throttle to where if you go full idle, it shows 0. If you go full positive, it shows 100, and you have to worry about that. But however, we're using a external ESC on an electric machine. We're running a governor mode on a cosmic ESC, so there's no need to worry about the throttle. No need to make any adjustments there. We'll set up the throttle later through the ESC itself. So there's nothing that you need to do to the throttle on your Vortex. So our sub trims are good for now. Then I take my radio and go to the travel screen here, endpoints, and we'll start backwards. We'll do the pitch first. So as you can see here, excuse me, pitch shows minus 95. Full negative pitch. I'm going to start increasing here until I see 100. I'm going to go to full positive pitch. And I start increasing here until I see 100. Then move over to rudder, and I go full left rudder, and I move here until I see rudder at 100, and full right until I see rudder at 100. Then we move left to elevator, full back elevator, and as you can see here, it shows 93. I'm going to increase that number until I see 100. Then full forward elevator, increase it until I see 100. And then the aileron. And I left the aileron for last on purpose because I see a little bit of a bug on some of these Spectrum radios. When you go full left aileron and you start moving the endpoint or the travel that corresponds to that side, it's usually affecting the other side on the Vortex. This is not only happening on the Vortex, but it's happening on every single flybarless system out there. I really don't understand what this bug is all about. But anyway, if I move full left, you'll see that aileron is 97, and if I start moving this, it just doesn't change anything. So I have to move right, increase a little bit, and then move left and keep adjusting until I find the right setting. So the right side is 96. I move left and I increase a little bit. Check. Now we're at 100. So now we've gotten everything the way we're supposed to. So our pitch, full negative is minus 100, full positive is plus 100. Our rudder, full left is minus 100, full right is plus 100. Our elevator is forward full is plus 100, back full is minus 100, and our aileron to the right is full at 100, and to the left it shows minus 100. So everything's good. If I let everything go, it shows 0 on everything, 0. If I center the stick here on the pitch, then it'll show 0. So everything's all good to go. So at this point, we're done with the transmitter trimming section. I push S, and then I move down one option. Next option is our sensor. So I'm going to push on sensor, and this is where I tell it which way the sensor is mounted. In my particular case, the sensor is upside down and with the wire forward. This means upright, and this means inverted. So I'm going inverted front, meaning it's inverted with the wires to the front. Push S. And then this shows me this graphical interface where I can basically tilt the helicopter left and right, back and forth, and move the tail and see if everything's working the way it should. Although this is a good tool right here. You always need, always encourage people to check the actual helicopter right before they fly. Tilt it and visually look at the swash to make sure it's correcting the right way. So I'll push S right now. Move one down, and next option is swash. This is actually a very important option here. Push on S. First thing here says digital or analog servos. Of course, it's digital. Push S. The type of swash plate, we're on a 120 ccpm swash plate, so that is correct. S again, and this is where we trim our servos independently. So I'm going to trim servo number 1. And because of the way I'm doing this video and the way I have my cameras mounted in the helicopter, I really don't have a lot of mobility. So I really can't do a perfect setup right now. But I'm going to try to get it as close as I can just by visually looking from what I can see where I'm sitting here. I'm going to go to servo 2 and do the same. And basically what you're doing here is just making sure all your 3 ccpm servos are lined up perfectly. They're straight, basically at 90 degrees. So I think that gets me pretty close right there. Then when you're done with that, you push S again, and then it's asking you swash servo match. This is where you check to see that the swash is moving in, that all the servos are moving in the same direction. Don't worry about positive being correct or negative or being backwards. Just make sure that all the servos are moving in the same direction. So if I move the collective stick in one direction, all servos should move together, and that is correct. If not, I would go ahead and select another option here, but since it's correct, I'm going to push S, go next, and this is now where we tell the system if the collective direction is correct. So this is where I move the collective stick up, and I look for the swash to move in the right direction. Since this is a Goblin 700, up swash means positive pitch. So positive on the stick should move the swash up, negative on the stick should move the swash down. That is correct. If that was incorrect, I would reverse that obviously. Then push S again, and then it tells me to align the blades with the boom, 0 pitch gauge on the heli frame and fit to the blades. So basically what it wants me to do is to align the blades the way you see them here, basically parallel to the boom, and it wants me to take a pitch gauge and zero it out, say on top of the motor or something that's at a straight angle, and then mount that pitch gauge on the blades. Once I'm done with that, I push the S button, and then this is where I tell it where the 0 degrees trim is. So at this point you want to read your pitch gauge and make sure it reads 0 degrees. Normally I don't use this to trim the 0 degrees. I make sure my helicopter is set up the best it can be mechanically. So at this point I would adjust these linkages right here, the linkages that go from the swash plate to the blade grips, and try to get as close to 0 as I can. But you can adjust this back and forth a little bit until you get it fine-tuned to be a perfect 0. Once you're done with that, you push S again, and then you go to the max positive collective. This means this is the maximum pitch you're going to run on your helicopter. I'm not installing the pitch gauge just to try to expedite the setup video, but for practical purposes, for instance, on this particular helicopter right here, believe it or not, with the BK servos and the SAB servo horns on the second hole before the last, I'm at about 12.5 degrees of positive collective with the 100 setting here on my data pod. Obviously, you need to adjust this to suit your desired collective amount of pitch and so forth. But I'm going to leave it here for now. Push S again, and then you do the same for the negative. So make sure you have the right amount of negative pitch. Then you push S again, and then you go to cyclic direction. This is where you move your cyclic stick. So you move the cyclic stick right and left and back and forth, and you make sure that the swash is moving exactly the way it should. Double check this, make sure this is fine. I actually, sometimes you can get distracted and miss something. Make sure that swash is moving correctly. If it's not, you have 4 different options here on the data pod that you could change to until you achieve the right directions on elevator as well as aileron. When you're done with that, push the S button again, and then you get to the aileron 8 degree position point. This is where you tell the Vortex where 8 degrees are on your aileron cyclic. So with the blades still the way they are, parallel to the boom, you would once again mount your pitch gauge right here, and then you would start moving your data pod up and down until you see 8 degrees on your blades. And you want to make sure that that's pretty close. Then you push the S button, and you get this message that says place blades perpendicular to boom, 0 pitch gauge. So now you're going to change the blades to a perpendicular angle to the boom. So just like that. And you're going to place your pitch gauge on the blades again. And then you push the S button. And this is where you're going to check for 8 degrees again, this time for elevator. So same what we did before with the aileron. You're just going to adjust this value until you reach 8 degrees here on your pitch gauge. When you're done with that, you push S again, and then you get to the cyclic limit portion of the setup. Cyclic limit is basically how much cyclic travel you have. So what I do here is I go to half stick and I just start moving full back elevator, full forward, full right, full left, and make sure nothing's binding. If something is binding, you can reduce this number. As you can see, it's set at 12 default. You can bring it down. I recommend not going below 9 degrees. That would be the lowest that I would ever do. If 9 degrees, you still have a binding problem, then readjust your servo horns and make sure you don't have as much travel. But normally 12 degrees works for most machines. So once you're done with that, push S again. And then you get to the cyclic ring taper setting. And this is where you check binding at extremes. So full negative collective, for example, full back elevator, you would check to see if you're binding. Same with full positive collective, say full positive or full right, full elevator, full left, full right, you'd see if you're binding. If you're binding at extremes like that, then you would increase the cyclic ring taper number up. And that would eliminate until you see the binding go away. Normally this works for, again, 95% of the helicopters out there, so no need to mess with it. And then we'll push S, and that concludes our swash section. Then we go down one more, and next up is rotor. So we push S, and then for rotor we have 3 options: normal, rigid, or DFC. Normal is for almost every helicopter that's out there. Rigid is for helicopters that have a more rigid head. So like for example, in the case of an HPS head here on the Goblin, the rigid would be the appropriate because we have plastic dampers. So it's a really tight setup. I believe the Align 700, the latest one, is also a rigid. I'm not sure, but it doesn't use your standard rubber dampers. It uses a more rigid damper. And then the last option is DFC. Obviously everybody knows what that is. I'm going to go to rigid. And I'm going to push S. Next up, it asks me the direction of rotation. Well, for most helicopters nowadays, they rotate clockwise, so I'm going to leave it alone. I think there's only a couple other machines that go counterclockwise. And then rotor face, we don't need to mess with that. Push S again. And then we get to the tail section here. Push S. First question it asks is the servo rate. So the servo type. So my servo is 760. And this is why I didn't want to plug it in ahead of time. Now that I have 760 and I push S, now I can go ahead and plug in my tail servo here. Let's go ahead and do that real quick. And there it is. It's actually quite alive, making a lot of noise. Then I check the servo direction, normal or reverse. I'm looking at my servo, my direction is correct. Push S. Then I trim my servo. So this is where you actually start moving this until you see that your servo horn is as close to center as possible. That's pretty good right there. And then the next setting here is the endpoints to both sides. So here you would start moving this up and down until you see your tail slider reach the end, and then the same with the other side until you see your tail slider reach the end. And then once you're done with that, you basically push S and you're good to go with that. So with the tail servo, one thing that's important is when you do this setup, make sure that you get as close to 200 total travel on the tail servo. So it doesn't necessarily have to be 100 to one side, 100 to the other. It could be 130, 140, and 60, or 120 and 80. But try to reach as close to 200 as you possibly can, because if not, the tail's just not going to perform as well. If you have less than 100, then go ahead and move the ball in the servo horn inwards, closer to the servo spline, to reduce your mechanical throw and try your endpoints again. And then when we're done with that, we go down, we go to the throttle, and basically the throttle is just where we tell the system what kind of throttle we're going to use. So we push S. So if you're running a nitro machine, for example, and you had a regular throttle servo, you would pick your servo type 1520 or 760 or 960. And since we're using an ESC, for ESC either analog or ESC works. Obviously ESC is the recommended method. Again, analog works just fine for most ESCs. And then K-bug is something that deserves some explanation. Some ESCs in particular, I've run into this with the Cosmic from Contronic, the Cosmic 160, the Cosmic 200. These ESCs have a built-in BEC. And when you first boot up your helicopter, whether it is a Spartan, anything, it doesn't matter. As soon as you boot it up, the ESC is looking for a throttle signal. And it has a very short timeout to get that throttle signal. If it doesn't see the throttle signal, it shuts down and it reboots. So what happens is, like, for people, if you talk about it, you guys might be okay. I'm not so sure. But I know that Spectrum takes sometimes 2-3 seconds to make a connection to the helicopter. And sometimes if the Cosmic doesn't see the throttle signal come reasonably soon, then it'll just basically go into that reboot, and then it creates this loop where you just see your vortex come up and you lose power and boot up again and lose power again. And all it is just that the Cosmic wants to see that throttle signal, no matter what kind of signal it is, but it needs to see a throttle signal. So what K-bug does here on the data pod is it just basically allows the Vortex to send a 0 throttle signal to the ESC immediately upon boot up. So at that point, the Cosmic ESC sees that 0 throttle signal, is happy about it, and it boots up its BEC, and everything's all good to go. The one thing I have to warn you about, and you have to be very, very careful with this, is make sure that if you're going to use the K-bug feature here, make sure that every time you plug in your ESC that your throttle is at an idle. If you could be in throttle hold, that's even better. Because what happens is, if you're flying Spectrum, you're using K-bug and you have a Cosmic ESC, and you plug in your main battery, your Vortex is going to send a 0 throttle signal to your Cosmic. Your Cosmic is going to see that, it's going to boot up, and then once your radio establishes, your Spectrum radio establishes that connection through your satellite antennas back to the Vortex, if your throttle signal is higher than 0, then the Vortex will send that to the Cosmic after it initializes, and it'll spool up on you. So be very, very careful on how you do this. A lot of times it's not necessary to use K-bug. Many times Spectrum can connect through its antennas and send that signal to the Vortex, and then the Vortex send that throttle signal to the Cosmic in a very short period of time. But there's other times when it just doesn't happen, and you'll just see the Vortex lose power and try to boot up again. If you're running into that, use K-bug, just use it with care. And after that, it says governor type, it says inhibit. I'm not going to explain how to use the governor for practical purposes and the length of this video, but once you learn how to set this up, setting up the governor should be fairly easy. So we're going to leave it inhibit, push S again, and we're done. At this point, we only have 2 more things here under the setup screen. We have Heli Wizard and Style Wizard. Heli Wizard basically populates every single parameter that you need to have for a particular helicopter. So the gains, especially the PID settings and all the gains and everything that has to do with that, will be populated and ready to go for a particular size model. So if we go to Heli Wizard, we push S. As you can see here, this is done by blade sizes, and it used to be done by helicopter size, but due to the complexity of different kinds of helicopters, whereas the Align T-Rex 500 is really swinging 425 millimeter blades, but the Goblin 500 is swinging 500 millimeter blades, it was decided that it was much better for this to be done based on actual blade size. So just pick the blade size of your helicopter. No simply means you're not loading anything. So for example, if you had a 700, you would go to 700, push S, and that's it. That loads all those parameters. It's all done. The next option is the Style Wizard. The Style Wizard basically populates parameters that have to do with the way you fly. So things like the speed of the elevator and the aileron, and the speed of the tail, and the amount of expo, and things like that. So if you click on it, then you can load the style depending on your personal preference. Newbie, Sport, 3D. There's a setting that says Bert that basically uses my settings, and the reason for that is simply a lot of people want to kind of know what kind of settings I'm using, so my settings are there. And then F3C. And you can see that there's a number, there's an N up here, and that is a flight mode. And again, we're going to talk about flight modes later. But if I wanted to load a style, say I'll load newbie, I push S, and then see, it wants me to do it again. Now instead of N, it shows 1. That's now flight mode number 1. So you basically have to do this multiple times depending on the flight mode you're going to run. And again, we're going to talk about flight modes. But if this is the first time setting up a Vortex, I recommend that you just load it on all your flight modes. So I would load a newbie, and then I'll load newbie again, and that way it's loaded on all the flight modes. So at this point, your helicopter is set up and you're ready to fly. Before you fly, make sure you check that everything is working correctly. Like I said before, just grab your helicopter and then just tilt it. If you go forward, thrust should go back. If you go back, thrust should go forward. If you go left, thrust should go right. If you go right, thrust should go left. And the same with the tail. Just yaw the helicopter, look at your tail corrections, and make sure without any shadow of a doubt that everything is correcting the right way. And again, at this point, you're ready to fly. What I really like about the Vortex is the fact that it flies well on all helicopters. You might want to fine tune it, of course, but at this point, this machine will fly really well. So stay tuned, and up next, we're going to talk about fine tuning the machine, making the machine fly exactly how you want it to fly, playing around with the rotor and the tail menus.